Hi everybody. We're going to look at a homework problem in section 6.6. These are all pretty similar, so I really only need to go through one of them. I'll show you the teacher preview real quick. The only difference between some of these problems initially is that the earlier problems give all the steps here. And of course, as you get later into the homework, I think I stopped helping in that regard. And then the other thing that happens is that some of these problems, like if you look at question 4 here, there's so many data values, and it's asking you to compute your own mean and sample standard deviation. There's so many data values that you have to, I recommend that you do it in Desmos with some instructions there. But then as far as the instructions on how to do the actual confidence interval, I stopped giving those eventually. So I'm going to go ahead and do one of these with you. I'm going to do one of them that does the mean and standard deviation on the calculator. And who knows, maybe I'll do one of the others with Desmos. So anyway, let me go ahead and I'm going to leave this preview mode and go in like a student. Okay, and so first question here, again, it gives a quick overview on the confidence interval for a population mean. We first verify the criteria that your sample size is bigger than 30 or we're sampling from a normal population. You get your level of confidence and the degrees of freedom, and population standard deviation's unknown, so you have to use T alpha over 2 for the critical value. The column heading is under alpha 2 tails, and the row heading is the degrees of freedom. Okay, so the margin of error formula is here. The endpoints of the confidence interval are there, and we'll go ahead and jump in right to this. So it says the weights of 35 randomly selected acorns from California black oak trees are recorded below. Construct a 94% confidence interval for the mean weight of California black oaks. Okay, so right off, I can go ahead and make a note here that N is 35. Okay, and our alpha value will be 1 minus the confidence level, which is 94%, so 0.94. And that'll be complements 0.06 here. The check, remember, is that your sample size needs to be bigger than 30 or the population has to be normal. So clearly I have more than 30 values here. So we'll check that off. And so the first question is, are the criteria for approximate normality satisfied? Yeah, it's because our sample size clearly here is bigger than 30. So we'll go ahead with that. Okay, that's good. And then the sample mean. All right, so I knew this was going to take some time, and so I opted to key in all these values ahead. So if you go into the data menu here on your calculator, you'll need to key in all of these if you're not using Desmos. And again, I recommend on these smaller data sets where it doesn't recommend Desmos, if you are not familiar with using the calculator, I recommend you do this. It's not hard and it's always the same every time. So I recommend you just key these in. So I would go in here, I'd enter these in, pressing enter between each one and just being real careful not to make any mistakes. Then once you've entered all the values in, you press clear, and then second data will take you into the menu for doing one variable statistics. So you select that menu item and just hit enter through these, and you'll get your mean and your sample standard deviation here. So in this one, these values have one place after the decimal, and with means we're supposed to do one more than what's given. So we're going to do 2 places after the decimal. That'll be 5.03 here. So we'll put that in real quick. 5.03. Standard deviation, that's a sample standard deviation, 1.47. Like that. And then our alpha we figured out over here is 0.06. Okay, degrees of freedom, that's the sample size -1, so I'll go ahead and put a note here for that. Oops. So with 35 degrees of freedom, sorry, 35 for the sample size, there will be 34 degrees of freedom. Okay, now we got to get this T alpha over 2 value. So that depends on alpha and the degrees of freedom, 34 degrees of freedom. So I'm going to pop up to table A2. Here it is. Okay, so again, our alpha is 0.06, so that's this column. Let me show this. Okay, so that column, 34 degrees of freedom is way at the bottom here, and then I'll just line those up. So it looks like 1.946 for that T alpha over 2 value. Okay, so let's pop back here. Okay, and I'll just double check it here before I do any other steps. Okay, and then I'll go ahead and do my check answer. Just, yeah, so everything looks great. And then we'll do our margin for error. Okay, so the formula, again, it's up here. Margin for error is this one. I'll go ahead and copy that. Now, just a kind of a quick reminder, we're using S instead of sigma. Sigma is a population standard deviation. S is a sample standard deviation. Of course, this is a sample standard deviation here, the 1.47. That was from the sample. It was not from the population of all California, whatever, black oak acorns. So it's just a sample. So you have a sample standard deviation and a sample mean here. And when sigma is unknown, that means we have to use T, not Z. Okay. If sigma is known, that was in the previous section, 6.5. So just to kind of make sure you got all that straight in your head, it's a little confusing. But let's go ahead and do our computation for our margin of error. So margin for error, the T alpha over 2 we've got here, 1.946. Times S, which is on the screen here, it's 1.47. Divided by the square root of n, and n was 35. Okay, so we'll pump that into the calculator over here. 1.946. Like that. Times fraction S, 1.47. And then divide by square root of n. Again, n is 35. Okay, and then I think we'll probably continue to keep 2 places after the decimal here, so it's 0.48. And we can put that in over here. Okay, and so that's all good, 0.48. Okay, and then for the lower limit and upper limit for the confidence intervals, that's just x bar minus e and x bar plus e. Okay, so the x bar was the, where'd it go? The sample mean up here somewhere. Yeah, x bar is 5.03. So we can put in the 5.03 minus margin of error, that's 0.48, and then plus okay, so let's do that. Okay, so here's our lower limit, and then I'm just going to copy paste that and change it to a plus. That's 5.51. Okay, so my limits here, what does it say? 4.55 and 5.51. I think these are grams. We have a confidence interval that uses these, so we know the means between x bar minus e and x bar plus v. I said we know, we think it's between these two values, so that the mean would be between 4.55 and 5.51. And we're 94% confident in that. Okay, so we go put it in these numbers. So lower limit 4.55, upper limit 5.51, and I'll put them again down here. Just double checking everything. Looks good. So everything's correct here, and then we say that not 94% of mean weights, 94% of the time, no, 94% chance, no. We are 94% confident, yes, that the mean is between 4.55 and 5.51 grams. And everything looks great. 8 out of 8. Okay, and then what I wanted to do is jump ahead to one of the other problems that uses Desmos. So I think, let's take a look here. Question 4 is a pretty good candidate for that. There's a lot going on here. And then I'm going to just do a quick cleanup on this. Just a moment on that. So that should be good. All right, so I'm going to do a copy paste in Desmos right now. So just real quick, I just need to grab all this, and I'll do a Command C to copy, and then I'll pop open Desmos here. It should open in a new tab. So in Desmos, you just say A equals this data set. So it looks like I've got part of this hidden. There we go. So A equals, and you do square brackets and paste like that, and it's a 101 element list. So we need the mean, so I think we just type mean of A, and the standard deviation STDEV of A. Right, okay, so we've got a standard deviation here of 3.73, looks like. And once again, all of our data values have one place after the decimal, so in our computations we're going to do 2 places after the decimal, always one more than what's provided. So I think I am going to just real quick make notes here. And I think I can just scroll this down a bit. I'm going to put my X bar here. Okay, so it says these are heights of 101 randomly selected women recorded below, and we want a 92% confidence interval. So the complement of 92% is 8%. Okay, degrees of freedom, 101 minus 1. So 100 degrees of freedom. Okay, so with a 0.08 alpha and 100 degrees of freedom, we can go ahead and go to our table here. So the alpha, again, this is table E2. So the alpha is 0.08. Degrees of freedom way down here to 100. And I think I'll just kind of zoom out. So it looks like we've got our number here, 1.769. Okay, so put that in right here. Okay, so then I think we have everything we need here to compute our margin for error. So again, I'll re-emphasize this. We're using this margin of error formula with the t-score because we're using a sample standard deviation, not a population standard deviation. That is, the population standard deviation is unknown, which means we have to use a t-score, not a z alpha over 2, like we did in the last section. Okay, so we can go ahead and run this formula. The t over 2 was 1.769 times s, which we did up above, 3.73, over the square root of our sample size, which was 101. Okay, so here goes on the calculator. Okay, so S 3.73 over the square root of n, that would be the square root of 101. And again, we're going to keep 2 places after the decimal, so 0.66. Okay, and now we're ready to compute some of the limits for our confidence interval. So x bar minus e up above, we have x bar at 63.50. And this will be minus 0.66. And then the same number, 63.50 plus 0.66. So we'll do these. Okay, so 62.84 for the lower limit. See if I can squeeze that in. 2.84. And the upper limit was 64.16. And I'll put those into my little confidence interval down here at the bottom. 62.84 and 64.16. And I think I'll just go ahead and zip over and answer all the questions in the problem here. So first thing it says is, are the criteria satisfied? Well, my sample size is over 30, and you have to either have more than 30 or a normal population. And on this one, our sample size is bigger than 30, so that's all we need here. And I'll put my little yes since n is bigger than 30. That'll be fine. The sample mean was 63.50. Okay, sample standard deviation 3.73. Alpha was 0.08. Degrees of freedom, n minus 1 is 100, so 100 degrees of freedom. T sub alpha over 2, 1.769. Margin for error, 0.66. Okay, fingers crossed, everything looks great. Okay, the lower limit for the confidence interval down here, 62.84. Upper limit right here, 64.16. And then we'll just key those in again. Should be okay. And then conclusion, we're 92% confident that the mean height is between, that actually says grams. That's hilarious. So this should say mean height. I'm going to go ahead and say in inches, and I'll try and get in and fix that shortly. And so that's all good. And then we got, as before, 8 out of 8. Feeling pretty good. All right, take care, everybody.